Hello, welcome to today's lesson. The objective today is scholars will learn to calculate the average rate of change of a function in order to interpret how a function changes over a specified interval. So we're going to start off with a quick refresh. Find the slope of a line between the 2 points and write the equation for the line in point-slope format. So, reminder that point-slope format is y minus y1 equals m times x minus x1. Okay? Reminder that the parts that will be replaced in this are y1, m, and x1 are the parts of this that will be replaced in this equation. So, first thing we need to do is find the slope. So, to find the slope, we are going to use our slope formula, which of course is y2 minus y1 divided by x2 minus x1. So, first equation, my slope is going to be negative 2 minus 4 divided by 10 minus negative 2. Of course, minus negative becomes plus. Negative 2 minus 4 is 6. 10 plus 2 is 12. So my slope is 1/2. So I have my 1/2, and then I'm going to use this point to write my equation. So my equation is y minus 4 equals 1/2 x plus 2, which would be minus negative or plus 2. And then I can rearrange it if I want, but there you go. Point slope format. Pause the video and do it with the second one. Okay, for the second equation, you should have gotten a slope of 2/3, which means our equation is y minus 4 equals 2/3 of x minus 6. Okay, so let's keep going. So where does it decrease the fastest? So this table shows the temperature in Tucson, Arizona, hours after midnight. When does the temperature decrease the fastest? Between midnight and 3 a.m. or between 3 a.m. and 4 a.m. So we're going to look at the difference in the slope. So first we're going to do the slope between midnight and 3 a.m. Between midnight and 3 a.m., the temperature decreases by 9 degrees over 3 hours. So 9 degrees over 3 hours, 9 degrees over 3 hours means that it's decreasing by 3 degrees per hour. Between 3 and 4 p.m., that's only 1 hour, the temperature decreased by 6 degrees. So it decreased faster between 3 and 4 p.m. because it decreased by 6 degrees, whereas between midnight and 3 a.m. it was 3 degrees per hour. That's all. So let's talk about this. What do we see on here? When we talk about average rate of change, we're talking about the rate of change between two specific points. So if you look, if I draw a line between any 2 points on here, if I draw a line between this point and this point, or that point, that very first point and this point, the steepness of the line is going to be very different. These 2 points will be connected by a line like that. These 2 points will be connected by a line that looks like that. Those have very different steepnesses. So when we look at average rate of change, we need to figure out what 2 points we are trying to find our rate of change between. And then we find the average by just connecting the 2 endpoints. So that is what we call the interval. The interval in mathematics is the set of real numbers lying between 2 numbers. The extremities of the interval, for example, the set of numbers x satisfying 0 is less than or equal to x, which is less than or equal to 1, is the interval which contains 0, 1, and all the numbers in between. So we would write that as 0, 1 would be the interval between 0 and 1. When we're talking about intervals, we are always talking about x values. Always talking about the x values of the intervals. Let's look at calculating it. So determine the rate of change over the interval 1, 3. So once again, we're looking at the difference between here and here. So I'm going to take those 2 points. So my point for 1 is going to be 1, and then I'm going to estimate that this is about 8. And 3 is about 26. And then I'm really just going to use my slope formula. So I have 26 minus 8 over 3 minus 1. Well, 26 minus 8 gives me 18. Over 3 minus 1 is 2. My interval is 9. My average rate of change, is 9. All it is that rate of change between those 2 specific points. So now if I look at this one, it depends what interval, what my rate of change is. So let's look at the interval -5 to 0. -5 to 0. So -5 is right here, and then 0 is here. So to look at these points, it's going to be, my points are going to be -5 and 0.8 and 0, 2. So change in y. So, -0.8. 2 minus -0.8 divided by 0 minus -5. So I have 2.8 divided by 5, which I put in the calculator to get a more specific answer. It's going to be a little more than half. That's 28 out of 50, which would give me 0.56. If I instead want to look at the interval between, oh, let's do a different color here. The interval between 5 and 10, it might be different. So now I'm looking at the difference between here and here. So in this case, I have the 0.52 and the 0.10, -2. So once again, I have -2 minus 2 over 10 minus 5, which gives me -4 over 5, which is also -0.8. So once again, it depends where my interval is, what my average rate of change will be. One more question. We're going to compare the tables, compare the functions represented by these tables. So I have function 1 and function 2. Which has the greater rate of change over the interval -2, 2? So, let's look at this first one. -2, 2 is this interval right here. So remember, it's change in y divided by change in x. So I have -6 minus 10 over 2 minus -2. -6 minus 10 gives me -16. 2 minus -2 because plus. So this is just -4 is my interval there. And then same thing for the bottom one, from -2 to 2. So I have 16 minus 1 over 2 minus -2. So I have 15 over 4, which is going to give me 3.75. So this one has the greater rate of change. Remember, we looking at greater rates of change, we are looking at the absolute value. If you have any questions, please come see me. Otherwise, go ahead and do your work. See you in class.